Algebra 2 students, to the homework help video, page 409. Let's go ahead and jump right into this. For numbers, let me look at my book here. Give me 1 second, students. For numbers 7 through 13 odd, we're going to write the exponential. We're going to write the logarithmic expression exponentially, okay? So here we go. Here's number 7 right here. Log base 3 of 27 equals 3. Now, the base right here is a base. Whatever the logarithm equals, which is 3, becomes an exponent. And the argument, whatever you're taking the logarithm of, is all by itself. There it is, just like that. Number 9. Your argument is always written all by itself on one side. On the other side, we have your base here is a base here, and your number here that the logarithm equals is your exponent. And there we go. Number 11. 32 is your argument. It goes right here. Then an equal sign. This is your base. It goes right here. And then your whatever the logarithm equals, it equals 5. That's an exponent right here. And there we go. Number 13. Your argument goes right here, and then an equal sign, and then your base goes right here as a base, and whatever your logarithm equals, in this case, your logarithm equals 3, it goes right here as an exponent, and there you go. So we just did 4 quick problems where we wrote logarithmic expressions. We wrote them exponentially, alright? Now for the next 4 problems, you're going to be given exponential expressions. You're going to write them logarithmically, okay? Alright, let's go ahead and get started with these. Number 15. Okay, students, we know we're going to write this logarithmically, so let's at least write the word log. We know the base of the exponent is always the base of your logarithm. Your the number over here by itself is always your argument, and the exponent is always what the entire logarithm equals. There we go. Alright, we know we can write the word log. Okay? We know that the base of the exponent is 4, so my base of the logarithm will be 4. The exponent is -1. That's going to be over here by itself. And this number here is the argument. So log base 4 of 1/4 equals -1. Okay, we know we're going to write this logarithmically, so let's go ahead and write the word log. Now, the number here all by itself is always your argument. The base of the exponent is the base of your logarithm, and your exponent is always what the logarithm equals. So log base 4 of 64 equals 3. Number 21. Okay, we're going to write that logarithmically, so there's my log. My base is 9, so we'll put a 9 here. This number's right here all by itself is your argument, 4.237 or 327 equals your exponent is what the entire logarithm equals. So the log base 9 of 4.327 equals 2/3. So those first 8 problems were nice quick review problems helping you practice writing expressions from exponential to logarithmic and from logarithmic to exponential. Okay? Now let's move on to numbers 23 through 34, and let's solve these logarithms without using a calculator. And here we go. First of all, we admit we do not know the answer, so we set it equal to x. Log base 5 of 25 equals x. Next, we write it exponentially. So here's my base. I write my base here. Here's what the logarithm equals x. That's my exponent, and your argument goes over here on its own. Now guys, that's really easy, is it not? We're solving for x, and what I've taught you to do is to get like bases on both sides. Well, if I have a base 5 here, I can easily write this with a base 5. 25 is the same thing as what? 5 squared. And now look, I have matching bases on both sides. Cross off your bases and set the exponents equal to each other. X equals 2. X equals 2. Let's try another one. Okay, the first thing you do is you admit you do not know the answer, so we put this right here. Equals X. Okay? Next we write it exponentially. Okay, so here we go. This is my base, so I write that as a base over here. The whole logarithm equals X, so that's my exponent. And then your argument is this whole expression right here. So I would put 9 to the negative 0.56. And look, you're finished. Your bases match. Cross off your 9's and set your exponents equal. And there we go. X equals negative 0.56. Now, may I please show you a shortcut? Anytime the base of the logarithm matches the base of the argument, whenever this number and this number match, all of this cancels out and you're left with just this right here. And that's what I was left with, this right here. So if I gave you a problem like log 8 to the 200th power, when these two numbers here match, you just cross off everything and your answer is 200. And you say, why is that? Well, I just showed you right here. Look what happened. When you wrote it exponentially, your bases matched right away, so these two had to equal each other. Okay? Alright, moving on to 25. That's a nice shortcut to remember. Please don't forget that. Okay, moving on. Log base 12 of 1 equals X. Let's write it exponentially. Here's your base, so put your base here. Here's X over here, that's your exponent, and then your argument, which is 1, is right here. Now, there is no way you're going to write both sides with a common base. Absolutely no way. There's no way you can make a 1 become a 12 or a 12 become a 1. However, you don't need to. This one is just common sense. 12 to what power equals 1? What do you remember? Anything to the what power equals 1? 0, right? Come on guys, think about it. Anything to the 0 power equals 1. So what number would you put in for X to make this equation true? 0. So then what does X have to equal then? 0. So there's the answer. Okay? Now, can I give you another shortcut, please? Shortcut number 1. Whenever this base here, let me clear some of this off. Whenever this base here, whenever this number and this number match, then you can cross everything off. Your answer is just this. Well, whenever your argument is 1, I don't care about anything else, your answer is going to be 0. The logarithm of 1 is always 0. How, Mr. Earhart, how do you know that? Well, I know that because, think about it, when you rewrite this, it's going to be 12 to some power equals 1, and I don't care what this number is. I don't care if this number is 1,250,000. If you put a 0 right here, it equals 1. So anytime these two numbers here match, cross everything off and that's your answer. It's a nice shortcut. Anytime you're taking the logarithm of 1, just stop and write down the answer. It's going to be 0. Okay, moving on. Alright, here we go. We do not know the answer, so we admit that and we set it equal to X. Now we're going to write it exponentially. Okay, here's my argument. It goes right here all by itself, then an equal sign. Here's my base, and here's my power. There we go. Now I want to get both sides with the same base. Hopefully you recognize this immediately what to do. It's very simple. I want to get both sides with the same base. Well, 81 can be rewritten as what? 9 squared, because 9 times 9 is 81. And then look, I have like bases, so cross off your bases and set your exponents equal to each other. And X equals 2. Cross off your bases and set your exponents equal. 2 equals x. And there's the answer. Number 27. Okay, we admit that we do not know the answer. Hold it. I see a shortcut. This number here matches this number here. So just cross all of this off, and your answer is this right here. 5/6. Now, if you want to see real quick how I can work it out, you'll see why it's 5/6. I admit that I don't know the answer set equal to x. Here's my base. This x over here is my power. My argument 4 to the 5/6 goes right here. And now you can see why the answer is 5/6. You have like bases. They cancel out. Set your exponents equal. And there's your answer, 5/6. Okay? Moving on to number 28. Alright, here we go. We admit that we do not know the answer, so we set it equal to x. Next, we're going to write it exponentially. So here's my base. It would be to the x power because I have an x here. And then my argument goes right here by itself. Now, obviously, I can write 4 with a base of 2. 4 is the same thing as 2 squared. But I've got an x here, so go ahead and put a parentheses and don't forget to bring down your x. Okay? Now, you know that when you have a power raised to a power, you multiply your exponents. So 2 times x is 2x equals 2. Look at that, guys. We have like bases. So we're good. Cross off what is your exponent right here, even though you can't see it. So 1. Cross off your like bases. Set your exponents equal. Divide both sides by 2. X equals 1/2. Alright, moving on to number 29. Okay, here we go. Now, guys, again, we can take our shortcut. Look at that. I'm going to do it the shortcut way, then the longer way. This number here matches this number here. So whenever this number here matches this number here, all of this cancels out, and the exponent is your answer. Let's go back 2 problems right here. This number here matched this number here. So everything was gone except the exponent, which was 5/6. That was your answer. Well, here, your 1/2 matches your 1/2, so they're gone with the log. And what's your power, even though you can't see it? A 1. So the answer is 1. Now, if you don't like those shortcuts, no problem. Work it out the long way, no problem. We do not know the answer, so we set it equal to x. Okay? Then we say, okay, here's my base, 1/2. And I raise that to the what power? To the x power. And that equals my argument, which is 1/2. And of course, 1/2 is to the what power? 1. Because anything is to the 1 power. Okay, look, you have like bases. Cross off your like bases and set your exponents equal. There's your answer, 1. Okay? And that's why you can use that shortcut. Number 30. Alright, we do not know the answer, so let's set it equal to x and solve. Here we go. Here's my base, 5, and I raise that to the x power, and that equals a negative 25. Now, here lies the problem, and I hope you'll listen to me, okay? The answer to this is undefined, or no solution. Now let me show you why. First of all, memorize this. You can never take the logarithm of a negative number or 0. Your argument right here can never be what? Negative, and it can never be what? 0. Please don't ever forget that. Your argument right here can never be negative, and it can never be 0. Please don't forget that, okay? So that's one reason it's undefined, but let me show you the logical reason, okay? There is no number in the world you can put in for x that will give you out a negative number. It's impossible. If you put in positive exponents, you'll get out a positive answer. If you put in negative exponents like negative 3, that does nothing but put the 5 on the bottom like this, with the 1 up top. You guys know how to do that. Bring the 5 down to the bottom, the negative 3 becomes positive. is still not a negative number. This is a positive number. I don't care what number you put in for x, this side here will never equal a negative number. It's impossible. So the answer is no solution or undefined. So you can memorize it, or you can try to work it out like I did here, and you can see it's not possible. Now, so your argument can never be a zero, and your argument can never be a negative number. Okay? Alright, moving on. 31. Okay, we do not know the answer, so we set it equal to x. Alright? Here's my base. I raise that to the x power equals my argument 1/8. Okay? Now, I have a 2 and an 8, so I'm kind of thinking, alright, this 8 right here is the same thing as 2 to the third power. 2 times 2 times 2. That's a 1 right here. So I'm getting a little closer. Then I'm thinking, hold it, I can bring this 2 to the negative 3 up top and make the 3 negative. So then I would have this. There's already a 1 up top, so 1 times 2 to the negative 3. There's nothing left on the bottom, so I put a 1. Well, 1 times anything is just itself, 2 to the negative 3. And if it's over 1, you really don't need to put that 1. So I end up with 2 to the negative 3. Notice I have like bases now, so I can cross them off. So my exponents equal. X equals negative 3. Okay? Alright, moving on to number 32. Alright, let's go ahead and set this equal to x. There we go. And now let's write it exponentially. Here's my base. I raise that to the x power equals my argument 1/3. Okay? Now, obviously I have a 9 and a 3, so it shouldn't be too difficult to write these with like bases. Okay? Here we go. 9 is the same thing as 3 squared, but I still have an x right here. Equals 1/3. Now, whenever you have a power raised to a power, you multiply those. 2 times x is 2x, so 3 to the 2x. I'm still not close to being done, guys. What about this 1/3? Well, hold it, I've got an idea. Let me come over here and fool around with this 1/3. I could take this 3 as a power of what? 1. 3 to the 1 power. I could bring this up top. So then I would have, there's a 1 up top already. Bring my 3 up top, that would be 3 to the what power? Negative 1. I have to change it from a positive 1 to a negative 1. There's nothing left in the bottom, so I'll put a 1. Now, 1 times anything is just itself, so 3 to the negative 1 over 1, or just 3 to the negative 1. So 1/3 equals 3 to the negative 1. And there we go. Now, do you see how your bases match? Cross off your like bases, such your exponents equal. 2x equals negative 1. Divide both sides by 2. And x equals a negative 1/2. X equals a negative 1/2. Alright, moving on to number 33. Well, we can stop now. We're finished. Undefined. You can never have a negative argument or a zero argument. Cannot do that. Will not work. It's not possible. Okay? Cannot have a negative argument or a zero argument. So the answer is undefined. Last but not least, hey, we're done. What a way to end. What is my power right here, even though I can't see it? A 1. Hey, whenever these two numbers match, cross everything off, and your answer is the exponent. So the answer is 1. If you want to do it the long way, no problem. Take your logarithm, set it equal to x. You have your base right here, raised to the x power. Your argument goes right here, has a power of 1. Look at that, you have like bases, cross them off, and set your exponents equal. X equals 1. Guys, I really hope this homework help video has been a help to you. You really need to be confident with writing exponential statements logarithmically and writing logarithmic expressions exponentially. Also, you need to be able to solve logarithms without a calculator. If you have any questions, don't hesitate to call or email.